Welcome to myprojectbazaar.com. Here we are going to discuss about distributive finite-horizon fusion Kalman filtering for bandwidth and energy constrained wireless networks. The state estimation is the sensor network node deployment is the most important process. The state estimation of each node distribution using the data fusion systems in a Kalman filter based approach discussed in this paper. A distributed finite horizon estimation algorithm is proposed for the networked multi-sensor data fusion systems in bandwidth and energy constrained network. To satisfy the finite bandwidth, the partial components are used. That partial components are declared in the fusion center to provide the communication on a constrained bandwidth and energy through the wireless network. The information from the channel is to be estimated for the random distribution across wireless sensor networks. Our focus in the distributed diffusion strategy is called being bandwidth and energy constraints, how the Kalman filter approach is utilized for the fusion estimation, and this algorithm extended to the nonlinear nature, that is called the extended Kalman filter. So the comparative analysis of Kalman filter, extended Kalman filter and fusion estimation also done in this paper. As the system architecture of our proposed work, it consists of 6 modules: node deployment, sensor pattern, distributed finite horizon estimation, fusion based Kalman filter, extended Kalman filter, proposed constraints. The random number of 100 nodes are deployed to describe the sensor network environment, and the sensors are used to estimate the node tracking objects. The tracking object which shows the number of time simulations, and the distributed finite horizon estimation. The finite horizon is the point in which the bandwidth and energy are constrained in this point. Using this module, the distributed parameters such as random number of positional error, velocity error and acceleration error, they are all estimated here. Fusion based Kalman filter, that is the fuzzy based initialization, that is to be declared in the fusion center. Using this fuzzy based estimation, how the energy, positional error, velocity error, acceleration error are varied, that is the estimation of this block. An extended Kalman filter, so the above linearized approach extended to the non-linear Kalman filter, that is termed as extended Kalman filter. Using this non-linear nature, the positional, velocity, acceleration errors are estimated. Finally, for our proposed constraint, how the energy and efficiency, bandwidth, capacity, that are all varied for this constraint, that is to be estimated in this block. Next we are going to discuss about the running procedure of our work system. It consists of several functions. The main function and several sub-functions are used to estimate the positional velocity, acceleration, error performance of random generation of sensor nodes. Now I run the main new program. This window shows our proposed work, the number of sensor nodes and the coverage range, simulation duration and number of trials, that are all described here. Here we are going to estimate the position, velocity, acceleration by number of events. So node deployment, number of tracking object, tri-sensor pattern estimation, FKMF estimation, EKF estimation and proposed constraints analysis. So the node deployment, here the random number of nodes from this strip line is selected. From this selection we can distribute the random network nodes here. Now first I distribute the random number of nodes, that can be 50. So here random number of deployment, that is to be displayed in this window. And the tracking of object, the number of tracking of object, set it as 1. So the tracking will be processed here. Object 1 is tracked. The rectangular, that is the red triangular value, tracks the object from the random position using this axis. So after the tracking procedure, the number of traveled nodes are displayed here. That will be termed as sensor nodes, and this is termed as sensor ID. Now the try sensor pattern window, the positional updation vector here, the displayed, which is the try sensor pattern panel, how the nodes are identified using the sensors and the occurrence of the sensors. When the occurrence of sensor, what is the source node, from the source node how it is reached to the destination node, and how this will be processed here. And the position velocity, this shows the several plots, that is SNR plots, the acceleration plots. So this is the acceleration error performance in time, that is to be displayed in this window, and velocity error plots, that is for time, and also positional error estimation has to be compared with the DKF model. And the spectral band of noise for a bandwidth is displayed in this window. The SNR variation for the number of nodes are displayed in this window. The energy level for the number of users in the sensors, that is to be displayed here, and bandwidth range also displayed. Then I switched on the DHF estimation. This is the estimated samples of our final sensor nodes, random selection nodes, that is to be displayed in this window. Then FKM of fusion based EKF comparison, that is to be compared with this algorithm. So the figure shows, each figure shows the how the EKF model is constructed from the random distribution of sensor nodes for fusion based Kalman filter and extended Kalman filter, that is to be displayed in this window. So velocity, root sum square of velocity error for the time duration is using EKF model, and this is the positional variation of various time values in EKF model, and the acceleration variation for the fusion based Kalman filter approach, and this is the velocity based model, and the positional variations for the fusion based Kalman filter is displayed in this window. Now I apply the proposed constraint. This constraint shows the several consumption of bandwidth energy oriented network, that is to be displayed here. The saved energy is increased in the FKMF model, and FKMF model, that estimation performance is the trace of the error, that is to be plotted for each time step values in this window. Positional error calculation for EKF and DHF comparison, that is to be displayed in these plots, and the bandwidth range for the different number of sensors partitions and another sensor nodes, that is to be displayed in this window. And the estimated bandwidth, mean sum square error performance for the extended Kalman filter and distributed Finite-Horizon Kalman filter is displayed in this window. Thank you.